Good afternoon, and welcome to the Using GIS for State and Local Government Asset Management webinar series. Today is the Broadband Infrastructure and Asset Modeling session. My name is Sara Taylor. I am with Texas 811, and I will serve as your moderator for today. So just a brief overview, broadband infrastructure asset modeling is a methodology used to assess the availability and quality of broadband infrastructure in a particular geographic area. And that's what we'll talk about today. We have several presenters for you. We'd like to start the session with a geographic poll, just to ask a few questions about our attendees. So in which organization type do you work? Where are you located? In which sector? What size is your city or municipality? So you should see the poll on your screen now. We'll give you all a few minutes to answer some of those questions. One of the things that we're going to discuss today is how GIS impacts this process, allowing analysts to visualize and manipulate spatial data. By using GIS in conjunction with other data sources, broadband infrastructure asset modeling can help policymakers and industry stakeholders improve broadband access and affordability in each area. So we'll give you another minute to answer the poll. And following the poll, we'll introduce our next speaker, who is Jeff Shaner with Esri, and he'll be talking about using Esri's ArcGIS field maps for broadband asset data capture. If you have questions during the session, we have a Q&A inside the webinar. You're welcome to put your questions in there, and we will answer questions following all of the presentations.
Would you like me to stop the poll now, Sara?
Yes, sorry. Go ahead and stop the poll. And Jeff, I will hand things over to you in 1 second. So who we have as presenters, who we have as attendees today, primarily in local and state government. So welcome to those folks. We also have some federal government, academia, and industry folks, primarily from the United States, and primarily in the land and public administration planning sector, public works and utilities, and other. Municipality size is pretty well distributed throughout the group. So thank you all for answering those polls. That gives our presenters some understanding of who they're speaking to. So Jeff, I will hand it off to you.
Thank you, Sara. Share my screen. So my name is Jeff Shaner. I'm the lead product engineer for our mobile application development at Esri. I've been with Esri for the past 28 years, building out different products from our desktop to dashboards to now mobile applications. And what I wanted to do in the next 15 minutes or so is talk to you about how you can take advantage of Esri's latest app, ArcGIS Field Maps, to do broadband asset data capture workflows. But first, I wanted to just mention that GIS is integral to the telecom lifecycle. There's various ways you can leverage Esri products, Esri mobile solutions throughout different aspects of the way you work with broadband infrastructure. And below are just a few of the field workflows that we've seen our customers engage in when using mobile applications for telecom use. And a link below at the bottom is a place you can learn more about the telecommunications industry and the GIS approach to it. So I encourage you to take a look there. So let's jump into ArcGIS Field Maps. ArcGIS Field Maps is Esri's latest mobile GIS solution. We introduced it in November of 2020, and it was a culmination of bringing together multiple mobile applications that we had in the past. Those applications run on iOS and Android devices primarily. We also have released it for Windows 11 as well. And it supports a variety of different workflows, anything from planning and coordination efforts using a map for spatial awareness, being able to do data capture, which is the primary thing we're going to talk about today, and being able to do asset inspection and integrations with other mobile products on mobile devices as well. So it's a holistic mobile application that has a lot of different capabilities that are rooted in your investment in ArcGIS as our primary product suite. So let's take a look at some of the broad capabilities that are available with the product. Looking at mobile devices and a mobile application on your iPhone, your iPad, your Android phone or tablet, you can use maps to gain spatial awareness. You can have maps actually talk to you. So leveraging aspects like your current location, you can leverage that location and the content in your maps to provide information that's relative to where you are and what you're doing. Likewise, maps aren't just like streets and place names. It includes all the rich information that's stored inside of the systems you manage. So you can present that information in a very kind of immersive way, where tapping on a map means you're getting back charts, you're getting back details and links and pictures and videos that provide additional context to what's around you, what you're working on, so you can explore the content that's there. And then we take maps even further inside of our mobile applications. With field maps, there's a concept in GIS called a utility network. So you can model the behavior of the way that the different assets work together inside of a system. And you can do things like tracing across a utility network, or isolation, or finding affected customers. We also support advanced concepts such as linear referencing, which is distance along a route, especially important when detailing out a transportation network or a utility network, and you want to know relatively how far apart things are from one another. But I think the most important aspect of the product that we wanted to talk about today is the data capture and editing experience. So with ArcGIS Field Maps, we've brought together the concepts of spatial data capture and form data capture into one unique experience. And we've fused together high accuracy data capture with the best of breed in GNSS receivers that are available through Bad Elf. We can support data capture both in a connected way, in a disconnected way. We can even support data capture both indoors as well as outdoors with the application. From a high accuracy data capture perspective, the capabilities are fairly simple. We can take the GPS position that your mobile device receives. That can be from a Bluetooth Bad Elf GNSS receiver, where those positions can get down to a centimeter level of accuracy. We can capture its location with its proper elevation value. As you're moving, we can capture linear assets or areas as well. You can use techniques like GPS averaging to improve the precision of the accuracy you're capturing. And you can work with real-time networks. You can connect to the receiver, but then you can define what's called a datum transformation when you're working with a real-time network and a map that's in a different coordinate system. And then, with Bad Elf, we've got a very special relationship, and we've done some integration with them to extend the capabilities with things like laser rangefinder integration. We're really excited about things we can get to in the future. Now, there's some really important things about capturing data with Bad Elf receivers that are important to mention. Inside of field maps, you can set requirements for the accuracy. You can notify mobile users when perhaps they drop a level of accuracy from let's say an RTK fix to a float position. You can prevent or warn them if they capture manual positions with the map. You can define a confidence interval, a streaming interval, the averaging interval. And there's a set of GNSS metadata that you can attach to all of the information you capture in the field so that you have this assessment of the level of accuracy of the information that you capture. The full metadata, all the information from the bad elf receiver is captured on points. We provide summary statistics for linear and polygon or area features. We also provide as files attached to those lines all the detailed information for each individual point that makes up a line or a polygon. And there's various different ways with Esri products to add those fields to the layers that you use for data capture as well. Now, probably the biggest, most exciting thing we've added into field maps as a newer product is something called smart forms. So you can, in addition to capturing all the spatial information with the accuracy you need, improve the efficiency and accuracy of the capture of the non-spatial data. And you can take advantage of this smart form concept to kind of provide an intuitive experience for how you walk through and capture information in a form. And that can leverage intelligence of other layers in the map as well if you want. And it's using a foundational concept that we have inside of ArcGIS called the arcade expression language, which lets you kind of extend and customize and essentially program what these forms look like and how they work and how they interact with the map and other layers. So that's a broad overview of field maps. What's new? We have a team of roughly about 60 people building the field maps product at Esri. So it's a major investment for us as an organization, and you can see that through all of the capabilities that we introduce through different releases throughout the course of a year. This was a culmination of the end of 2022 through all of last year, and you can see a number of the key features that we added to the product. We release this product 3 times a year. That's our major releases that we have. We have minor releases in between. Our next release is scheduled for February of this year. Field Maps is mobile application is complemented by a designer web application that lets you configure the experience. We have a whole bunch of new capabilities coming into it. You can see all of that here. And then throughout the course of the year, we've got a lot of work ahead of us. Probably the most exciting thing that our customers have been asking us for is the integration of a capability called tasks. So we'll be bringing another mobile applications concepts into field maps. That product was called ArcGIS Workforce. That will be manifesting itself as this concept of tasks. We'll be starting early adopter beta programs for that very soon. So please look for more information on that. But what tasks will let you do is plan and assign work, let you communicate between the field and the office, providing essentially to the mobile worker an interactive to-do list that helps them accomplish all of their work in one simple, easy to use application. So that's my brief presentation on field maps for you today. With that, I'm going to stop sharing and pass it over to Catherine Crook. Catherine's a former enterprise GIS manager for the city of Kent, Washington. So Catherine, would you like to take over?
Okay. So a little bit background here. I'm currently the senior program manager here at Hexvarium, which is a fiber analytics company, and I am speaking later on that behalf. This current segment is for me to speak on my government background and how broadband is the non-utility utility. We are currently in a space where we don't talk about it very much. I've had a lot of problems with it over the years. I've had 20 years in government. I've set up GIS for large cities here in Washington State. And I also teach GIS at Seattle University and the University of Washington. None of those platforms allow us to talk about this in a way that's allowing us to come out of the COVID environment and realizing that there was a lot of issues with students and staff not being able to work from home and get access to the resources they needed. So that being said, we came back to work 2 days a week, and we had to start looking at, from a government perspective, assets and how we were going to manage those moving forward. And broadband and fiber bubbled to the top due to the fact that we just came out of the COVID environment. And well, we're still kind of there, but we wanted to make sure that we were looking at this a little more solidly. And as I realized, like most of you do, that we've been told that a lot of you come from the government sector, is that we struggle with broadband and assets because we don't know where they are. I had over 400 as-builts that were sitting in a cupboard or in some type of format somewhere around the city that we needed to digitize and get into a asset space so that we could bring on the GIS and better understand how that moved from the field into planning and then into maintenance and asset management. And we chose at the time to go ahead with the CityWorks, which is an Esri partner. And through our work with CityWorks, we were able to allow for a better understanding of current assets. The one that was missing was broadband. So we did not realize where broadband was at the time. So we wanted to talk about spatial visualization. We wanted to do data integration with it and risk assessment and decision support. But unfortunately, we just didn't have a baseline. We didn't really know where our fiber was. So a lot of this came up with, well, we don't track that. We seem to track even our garbage. We track what provider, where they pick up, where they don't. When anybody comes into the city, we have a lot of utilities that we allow them to have access to. But because we don't control garbage or electricity, usually at a city jurisdictional level, we kind of leave that to those providers. But we work well with them and we have partnerships with them. What we don't have partnerships with is fiber and broadband companies or ISPs. That comes probably to no shock to anybody, as we sit in a landscape where we struggle communicating with them, thus we don't know asset-wise where they are. Permitting is a big issue. We sat with permits for 3 years. Larger ISPs would come in and pull a permit, then never do the work in the ground. They would come back later, reapply for the permit, causes more waiting and struggling in that space, and they still would never do it anything in the ground. So we need to, as a government agency, local and jurisdictional, is to take that power back. We need to provide them with the conversations so that we can say, no, you want to come and work within our city boundaries, we need to know where that asset is. I've written many times into a franchise agreement that you must give us the location of that fiber or asset. And unfortunately, it's never seems to be adhered to. So, which is why I was really happy to see Esri on here too, because that is a major component of tracking and better understanding where that asset lies so that we can force it into the system. We have so many assets that we're keeping track of that water, sewer, electricity, and garbage are basically well understood within our umbrella. Fiber, we don't understand it. And as a government space, we are a little scared of it. They kind of come in and push us around a bit. And we need to learn how to kind of push back a bit on them and say, that's fine, but these are the things you would need to adhere to in order to come into the city's boundaries. There are meetings that need to be taking place, conversations that need to be had with I know, I don't know if any of you, but here in the Washington state, there's a very large one that's coming in and blind calling a lot of local jurisdictions and asking very, very pointed questions. And we need to make sure that we are bringing them to the table and having those conversations. We want to make sure that we are providing the taxpayers with the proper information that they know when they come into the city, that we provide them with information on where you can pick up your garbage, where you can get your what fiber networks are available and cable is available within the area. And we don't do a really good job of that. By giving efficient planning and development and network optimization, we are able to give them a lot more information so that they can better understand the options around them. One of the biggest pushes right now is BEAD funding, which is approximately $43 billion that was released by the federal government after COVID so that we could get those vulnerable, hard to reach places. And what some of us don't realize is those hard to reach, vulnerable places are here in our own very urbanized boundaries. I know the city I worked for, they had a really good, so they thought, but when we really looked at it, there was really large pockets of areas that were vulnerable and did qualify for funding, but we did not put a package together. We are now, they did now, but previously we never thought about it because we weren't doing the spatial visualization and analysis needed to be able to provide the data to give them those pockets of areas that were really struggling. Comprehensive data management. So where are your assets? How do they come in? What are we doing them? We don't really manage fiber assets in a city environment, but we do manage contracts with them. We do manage where they are locating and placing fiber down. And we need to be able to track that and have a really good, concise layer to be able to do any type of real-time asset tracking as was provided that previous presentation. And all of those tie into each other, and we need to do a better job of kind of like building a structured plan on how to manage that moving forward. It will identify vulnerabilities. It will give us abilities to be able to see where those vulnerable people that don't have access to the things that they think they have access to. And we should be able to use the funding that's around us and the grants and the various awards to be able to place that there. There are a lot of locations in rural regions that don't have access to this, but at the same time, they're here in our backyard in urban environments as well. Decision to support. I don't think we're talking about this. We're not planning around it. We're not utilizing the funds and the availability and hitting deadlines the way we should. There's a digital divide that we've been talking about for years and years and years, and we need to really spend our time looking at that and putting it in our yearly planning projects of where are those vulnerable locations, where do those problems reside, so that we can have a better understanding and close those boundaries and the gaps and provide to them. A lot of local communities, when they don't have access to the funding on their own, they'll band together, they'll form consortiums or community groups that allow them to do it as a whole. I've seen that a few times here in Washington State and other areas. And being able to understand where our assets lie gives us the power to manage them better, but also make decisions based off of who's coming into our area, who's providing us with this utility access, and so that we can manage backwards and instead of forward. We can't be in a space where we're allowing them to make decisions for us anymore. The money and the funding, when available, is there, and we really need to take advantage of it. So that's what I have today. So thank you so much. So with that, I would like to introduce my next person on the panel.
Dr.
is,
Nikolas from Bad Elf. Thanks,
thank
Nick.
you.
Hey, no worries. Voice in the background. And also thank you, Catherine, for that fabulous presentation. Let me go ahead and share my screen. Hopefully you can hear me and see me. Here we go. Okay, so I guess I just want to start by saying thank you, Jeff and Catherine, for those first two presentations. They set a great stage for a quick discussion I want to talk about that I'm calling Navigating Broadband Mapping Success with GPS and GIS. Jeff did a great job from Esri's perspective on setting up the context on why or how GIS and GPS is being utilized to assist in the telecom broadband industry and space. And then additionally, Catherine, you had a great discussion on some of the more pertinent things happening in today's marketplace around broadband infrastructure. And you're going to see that I'm going to flesh both of those out today. My name is Dr. Nikolas Smilovsky, and I am the Geospatial Solutions Director for Bad Elf. So let's dive in. So it looks long, but it's going to be very short. We're going to kind of continue the discussion that Catherine started on what I call the current state of broadband affairs. We're going to discuss quickly who Bad Elf is, and you're like, the who and the what, maybe if you've never heard of us. We're going to talk a little bit about the importance of the system of record, particularly digital systems of record. And coming from a telecom background myself for a number of years, I can say that there is a digital divide, and I agree with Catherine's sentiment. We'll talk about how we go out and collect these assets for these digital records. We'll talk about some custom solutions, how you get there, and we're going to wrap up with a very friendly kind of discussion on what are called smart cities. So current state of affairs, building on what Catherine just laid out in front of us. I'm going to read these, even though you're not supposed to really read off of the screen, but I think it's important. Mapping matters. The US still lacks universal accurate broadband access maps, hindering targeted infrastructure expansion. Recent efforts like BEAD prioritize mapping unserved areas. Catherine mentioned BEAD. We're going to get to that in a moment. There's a huge policy push in the United States currently. The Infrastructure Investment and Jobs Act injected $42 billion into broadband access, making historical federal commitment, but deployment and accountability face challenges regardless. We've got a huge focus in the rural communities, even though there are underserved urban communities. Closing the rural-urban digital divide remains a top priority. BEAD prioritizes unserved and underserved rural areas, along with anchor institutions like schools and hospitals. The idea here is that in 2024 and beyond, it is inequitable to not have access to the internet. As a teacher and professor at Arizona State University as well, when I put that hat on, I can tell you that after COVID, access to school, for an example, like those anchor institutions, was difficult. If you did not have high-speed internet to connect into class, this was a very difficult thing. Today, if you need to go get services from your local or state government, maybe like driver's license or insurance, or you've got to apply for a permit, all these sorts of things are now being online and they're digital. The days of being able to walk into offices and write paper checks and fill out paper submission forms are going to the wayside. My wife and I are in the process right now of working on a piece of property, and we got power and fiber installed just recently. That power and fiber installation, it was completely done remotely and digitally. So if you don't have access to that digitalness, right, via the internet, via broadband, you are seriously in a hole and you're fighting your way out of it. Fiber and fixed wireless deployment dominates long-term plans, but fixed wireless solutions gain traction as faster, more cost-effective options in challenging terrains. Not to get political, but for an example, if you are coming here as someone seeking asylum, for an example, our US government gives you a cell phone. That cell phone has wireless capabilities to connect to the internet. So then you can, say, go to your court meeting or go to the services that are needed. The point I bring up here is not to get political, but to show the importance of having broadband and having that wireless connectivity. There was also a large push recently on the small cell network, so creating connectivity in a smaller form versus, say, the large cell towers. And I mean, there's huge market momentum as we go more and more digital, things like AI and machine learning and augmented reality and all these things that we are dealing with. They all sit on the backbone of the digital internet, right? So the US broadband market only continues to grow. It's expected to reach about 180 billion by 2027. And so competition rises. And so you need to find ways to better compete in the market. That's where Bad Elf comes in. We create great GPS, GNSS to collect the assets. We have enablement teams that can come alongside you and help get you all digital. We work with partners like Esri to help bring in custom solutions, which we'll talk about. We mentioned BEAD earlier. Also, as I said, Catherine mentioned it as well. This is important. BEAD, the Broadband Equity Access and Deployment Program, is a major initiative launched through the Infrastructure Investment and Jobs Act. So BEAD, Broadband Equity Access and Deployment. Again, everybody in America, it's now been decided, needs to have internet access. This is a huge gap in the market. And this is where everybody, I'm assuming here, whether you're a state and local government, fed or private side, this is why we're here. We want to learn about how we can better serve our constituents and customers. The aim here is to bridge that digital divide by providing substantial funding for this infrastructure so that that cost is not just falling on the local communities. This helps expand broadband access, promote digital equity, and boost adoption affordability. Okay, so who the heck is Bad Elf? Now that we've got this stage where we need digital records for telecom to make sure that we are serving our country, right? That's where we're at. So who's Bad Elf? We've been around about 13 and a half years, a little over 13 years. We create GPS equipment for the GIS survey markets and other alternative kind of adjacent geospatial markets. We approach data collection agnostically. We work with all iOS, Android, and Windows applications. You can bring any phone, tablet, or laptop to the mix. We have a great business relationship with Esri. So Jeff was mentioning field maps. We've got some direct integrations right into field maps, Quick Capture Survey 123, among other options. The other thing is we have an entire team of professionals dedicated to enabling you. We like to call it taking you from zero to hero. I think I actually have that on a later slide. Sorry, I'm getting excited. But our geospatial enablement team is here to help you actually go from that maybe more paper-based, more analog-based system of telecom to the future. Again, we've got a lot of experience in that fiber to the home, and we understand the small cell world. So you can leverage us to help you. So why telecom system is a record? Well, you've got to have management of the inventory. You can't get more money unless you know what you have. You can't really install more things correctly and efficiently unless you know what you have. And so maintenance planning and the life cycle, that's sort of what the digital twin is, 4, 5, 6D, right? It's not just where it is in the world, it's how much does it cost, what's its longevity, what's its business ROI. So having a good digital system of record, where are your assets in the field, and then being able to access that record, right? You're able to send resource allocation. You can use things like workforce within field maps to send out crews to do different work. Of course, compliance and reporting. Again, when you talk about money, you can't get some of this federal billions if you are not staying in compliance and you're reporting these things to the correct agencies. We also have more regulations coming down the road, things like subsurface utility engineering, or what we call SUE. SUE is standardized by the American Society of Civil Engineers, so the ASCE. So this is a big deal, right? Like if you're in, for an example, in Colorado, you can't build within the right of way. You can't install your broadband infrastructure without having an accurate, map or as-built SUE diagram stamped by an engineer, stamped by a surveyor, or you can't build. And Colorado is just one state. There's many states adopting these types of policies. There's also local municipalities and government agencies, like on a state level or a county level. They're also adopting these things. We also heard earlier from our awesome moderator, Sara Taylor from Texas, here in the DFW area. I'm a little south. I've known Sara for some time. Thank you, Sara, for committing this time to us. She works for 811. So talking about compliance around utilities, calling before you dig, this is really important. Knowing where your assets are help mitigate outage and disasters, right? So critical failures can be mitigated and stopped before they start by having a better system of record, truly knowing what you have and where you have it. So that leads to these data-driven decision making. We're not licking our finger and seeing where the wind's blowing today, and we're just like going willy-nilly left and right. There's just like cities are master planned, communities are master planned. We're now, it's a world where master planning is involved in the telecommunication. How are you rolling this fiber out to the communities? And we've mentioned it a few times now, diversity, equity, inclusion. We live in a world now, again, that you basically have to have access to the internet to have a chance, right? We mentioned earlier, all the services wrapped around online infrastructure. So how do you go collect those assets in the field? Well, hopefully you call me, you call my team, you pick up a Bad Elf GPS, a global positioning system, or today we call them GNSS. That's just a little bit fancier term called Global Navigation Satellite Systems, more archetypal in terms of it also includes systems from around the globe. So depending on what you're doing, we have fully survey grade Bad Elf Flex, engineering grade, AEC, you're laying down centimeter or better type of data, or we've got our Bad Elf Flex Mini, newly released last year at the Esri Users Conference, which is going to get you to near survey grade. So if you're collecting a telephone pole, or let's say you're collecting conduit, you may pick your device depending on the types of accuracy. So if you're in engineering and you have a small 1-inch conduit, maybe a 1 centimeter device like the Flex, or if you're looking at a telephone pole that has a 1 foot diameter, perhaps a sub-foot device would work for you. At the end of the day, I just want to tell and challenge everybody out there, when you go to collect data, there's lots of GPS receivers on the market. Do your due diligence. Bad Elf is just one of them. Personally, I think we are the coolest named, and our marketing branding is the coolest. We also have some of the best pricing on the market and support, but just do your due diligence before you go out and collect data. Talk to your local Esri rep. They can also give you some information. You can reach out to myself, Jeff Shaner, amongst others, and we can help you get set up with, say, field maps and Bad Elf devices. So we mentioned that Bad Elf makes devices, but we also create custom solutions. So the Geospatial Enablement team, we work alongside of our R&D team. And so we've integrated peripheral devices like laser rangefinders, LTI, for an example, or Hagloff. We've been connected into utility locators if you're looking underground, but you name it, we've been connected. Our actual Bad Elf Flex app, which is free on the App Store and iOS Store, is the utility app that connects your peripheral device, your GPS, and your phone. And so we use a checklist system here on all of our Bad Elf apps, because we're a bunch of pilots, and pilots know to keep safe and to keep quality high, you need a checklist. And so here's on the screen, you can see literally a screenshot of our app. And the thing I want to make really apparent is that we have custom coding behind the scenes. We've worked with the Field Maps Mobility team with Jeff, and we can literally pass offset measurements, both horizontally and vertically, to field maps. And that all happens underneath the hood, populating your feature classes and your digital record pretty seamlessly. So this is pretty amazing, if you ask me. The guy you see on screen here, this is Chris. Chris is one of our geospatial enablement team members. He helps people like yourselves get from zero to hero. We keep talking about how do you get there, geospatial enablement team. So at Bad Elf, we have a whole team that you can leverage, get from the beginning of digitalness to being an expert. Let us take the hits so you don't, so we have expertise in GIS and telecom and GPS, obviously. So if you want to go out and collect some data today, talk to us. Like, you don't necessarily have to bite off and save the world and, cure cancer and climate change and equitability, but maybe you just need to start collecting some utility asset. Maybe the start is cable pedestal boxes, right? So you need to go do a pedestal survey. Let us help you get there, and we can help you there. We can shave off some of the fat around Esri, all the amazing things it can do, and help create a custom solution just for you, get you off the ground so that you're talking to your boss, your stakeholder, your constituent immediately within days, and you're being profitable and you're doing the things that you need to be doing. This team literally provides turnkey options for you, depending on your needs. That those consulting packages can highly be diverse, from teaching you how to use ArcPro to custom setting up field maps and different ArcGIS solutions, to coming on site and doing training around drones and FAA 107 if you want to fly these towers, for an example. And I just want to mention again that we heavily leverage Esri. So if you are already an Esri person, and this just reminded me, if you would, could you go ahead and throw up our geospatial poll? We've got a quick poll talking about a little bit more about geospatial solutions. And if you are interested today about solutions. So if you wouldn't mind quickly, do you have a GIS staff today? Yes or no? Are you interested in implementing solutions? Yes, no, or maybe. What kind of time frame do you have? And then where would you be planning these solutions? So you should see a window pop up on your screen. If you could just spend just a couple seconds, click those radial boxes, and then we'll review those answers here. But the idea here is that I kind of want to know, do you have a GIS department in your agency or your government, job, or even on your private side? Are you a CLEC? Do you have a GIS group? Are you looking to do solutions? And so go ahead, click those survey buttons real quick, and we'll give it another 15 seconds, and we'll review that. The key here is, if you are interested in solutions or GPS or Esri or just further talking or education, let us know. And you can let us know by this poll. We certainly will have some follow-up following this great webinar provided by Connect Me. But this is your opportunity to give some feedback. So why don't we go ahead and throw up the results of the poll? Hopefully that was enough time. So it appears that it's almost an even split. About 50% of you all have GIS departments, which, bravo, by the way. Absolutely, like, everybody pat yourselves on the back. Everybody who has GIS, you make my heart happy. Now, the other 44% who do not, we're going to get you on board here sooner than later. Are you interested in implementing a geospatial solution? 47%, about half of you said yes, so that's great. Funny enough, about 8% of you said, no, computers scare me. I get it. You're not the only people in telecom that's still designed on napkins. I get it. That's a bad joke. But we can help you get beyond the fear of computers. We're here for you. What kind of time frame are you looking? Evenly distributed from like almost right away to this year to never. And then, are you planning to do it internally or externally? And most of you are looking internally. So that's some great information. Thanks for doing that. Okay, so I'm going to end my presentation here with a little bit of a forecast into our future. I know 2024 in the United States is going to be a tumultuous time, most likely. I know we're going through some crazy weather events today, and the world's got some, things going on. But what's important to me, and what I'd like to convey to you, is broadband is the backbone of tomorrow's city. And tomorrow's city, that smart city, we call it, needs telecommunication infrastructure. And that infrastructure is going to run these cities. And if you don't really know what smart cities mean, imagine these cities that location-based devices and cameras and sensors, they make smart decisions for you, the people living in the city. And so these cities can be more green, more sustainable, more LEED. They can be more connected, more inclusive. They'll be adopted and ready for things like autonomous vehicles and drones flying us around. It truly is an exciting future we have, but we can't get to the smart city of the future unless we have the telecommunication infrastructure today. And so please consider going out, mapping your assets, adopting GIS. It's not only going to help your organization, but it's truly going to help our cities of the future. This is where half of the world's population live. And so I think this is an important call to action. So thank you. Let our partnerships enable your geospatial successes. Please reach out to me at nick@bad-elf.com, or you can email us at get@bad-elf.com. Visit our website. Now, without further ado, I would like to introduce our next presenter, a good friend of mine and former colleague, Andrew Nash. Andrew Nash is the GIS manager of BPG Designs. Let me stop sharing my screen. I go a little ways back with Andrew, and I have to say it's always great being on an event like this with you, Andrew, and seeing you do all the great things that you're doing in the industry. So kudos, sir, and why don't you take it away?
Awesome. Thank you for the great introduction, Nick. Definitely very excited to be here today. Let me go ahead and share. Fantastic. All right. So I'm here to talk about revolutionizing telecom and GIS today. First, just hi, everyone. Welcome to my presentation. And I'm just really excited to be here and to get started. A little bit about me. I'm a GIS project manager in the telecom industry. I've been responsible for the direction, coordination, implementation of GIS telecom projects for some pretty large companies, Google, Verizon, Cox, which is a local broadband company here in the Southwest, and then Facebook as well. Some of my previous work experience is a GIS mapping technician at Southwest Gas and a Salesforce software developer. And then my education, like Nick said, we go back quite a bit here, and I got a bachelor's of science from Arizona State University, and then a GIS certification from ASU as well. So go Sun Devils, we are representing well in the GIS and broadband industry here. Today for my presentation, I want to cover two specific areas that I feel are pretty important to GIS and the telecom industry. Network planning and field data collection. Network planning, it's an incredibly powerful tool. Utility network planning is the process of creating and managing a GIS representation of utility networks. These utility networks typically include systems such as water, gas, electricity, wastewater, and most specifically for today, telecommunication networks. Planning these networks involves capturing, organizing, analyzing, and visualizing spatial and non-spatial data related to those networks. It enables better management decision-making. Specifically for the telecom industry, you can see there's four big areas that we like to focus on using GIS for. Site selection. The GIS can analyze various factors such as population density, geographical features, and existing infrastructure to identify optimal locations for towers or antennas as it relates to cellular telecommunication networks. We also use it for coverage analysis. GIS can model the signal propagation and coverage of proposed networks. It helps in understanding the service area of each tower and identifying any coverage gaps. And then also with capacity planning. By analyzing the usage data and traffic patterns, GIS can help in planning the capacity of each site to ensure quality of service. And the big one that I've been involved heavily with, especially over the last few years in some of my projects, is route planning. For wired networks, GIS can help in planning the optimal routes for laying cables while considering factors like terrain and existing infrastructure or legal restrictions. On the screen here, you can see an example of one of the projects that my team has been working on in the telecom industry. So spatial analysis techniques can be applied to perform network modeling, capacity planning, and outage management and asset management. Visualization tools can display the network infrastructure, highlight critical areas, and provide insight into the network's performance. And as you can see here, this is a fiber optic network to feed fiber to the home in a local neighborhood here in the Southwest. These interactive maps and charts and reports can be generated to communicate information effectively to stakeholders. And the network plan is an ongoing process, right? It requires regular updates and maintenance to ensure the accuracy and reliability of the data. It serves as a valuable tool for utilities to effectively manage their networks and improve operational efficiency. And then the other big item that we're seeing on the network planning side is fiber optic splicing software. So these fiber optic cables, they come with thousands of individual strands of fibers in them. And we don't just map out a route for the cable as it relates to a geospatial area. We actually route out the individual strands inside of the cable. So we're mapping thousands of different strands per cable. We're mapping where they go to, the signal strength on them. And like I mentioned before, so this helps with planning and capacity management for these telecom networks as it relates to designing it, implementing it, managing it, and then troubleshooting areas as they might have outages and things like that. And then for our second agenda item today, we got field data collection. GIS plays a vital role in the maintenance and operations of the telecom industry. As Nick was going over with his slides, you can see that monitoring and managing infrastructure, GIS offers a comprehensive solution to monitor and manage telecom infrastructure by integrating relevant data such as equipment location, maintenance history, and performance metrics. Companies can employ predictive maintenance strategies, optimize resource allocation, and extend the lifespan of their assets. For field operations, GIS enables telecoms to modernize workflows with custom solutions for the field and office. It can help with the telecom industry with increased access and reliability of infrastructure data, simplify planning, decrease operating costs, and improve the response time to network issues. And then GIS helps in managing, enhancing, and sharing data. This ensures that the most accurate and up-to-date information is available for decision-making and operations. And here you can see some snazzy images of some of the field collection data that we've done here with the company that I work for. Specifically, the mobile LiDAR is one of our big scanners. Mobile LiDAR scanning offers significant advantages over traditional survey methods as it allows for rapid data collection over large areas, reduces the need for manual measurements, and provides highly detailed and accurate 3D information. It has numerous applications, including road, highway mapping, urban planning, forest management, utility mapping, which is what we do here. The LiDAR feature extraction, which you can see in the top left corner, is the process of identifying and extracting meaningful features or characteristics from a LiDAR point cloud data set. LiDAR technology uses laser pulses to capture detailed 3D spatial information of the environment, resulting in a dense point cloud representation of the scanned area. And then extracting features from the point cloud is crucial for various applications, including object detection, terrain modeling, urban planning, and autonomous navigation. For telecom, we use the feature extraction to produce detailed layouts of utilities and city infrastructures to help our drafting and permitting teams. During the feature extraction process, we collect sidewalks, roadways, handholds, signs, poles, really anything that you can see in the data. We're going to go ahead and pull that out to put together a high quality permit that we send over. And then some other items that we use in the telecommunication industry as it relates to field data collection, like Nick has mentioned, GNS receivers are used to collect precise data location. You can see a Bad Elf one there. We also use some Leica range finders. We also use smart devices like smartphones or tablets, often used in conjunction with data collection apps and similar products to what were mentioned earlier, like ArcGIS Quick Capture, Esri Collector, and Survey 123. For the rangefinders, we use a wide variety of measurements, but most often it's used for measuring antenna heights, During site inspections, rangefinders can verify positions, height clearance, elevations, various elements to ensure the measurements are accurate. And they're also used for tower mapping, which involves measuring and recording the details of the tower structure. But by using the laser finder, telecom companies can collect a variety of measurements for a single vantage point, speeding up the collection and improving the accuracy. And then, like Nick had mentioned, just remember, the choice of equipment can greatly influence the accuracy of the data. So just make sure you take your time, you do your research, and you purchase a good, high quality product to make sure you get high accurate results. All right, so that's all I have. Thank you for taking the time to allow me to share this info with you. I really appreciate being here, and thank you again to Nick for bringing me in. And then I'd like to turn it back over to Catherine Crook.
Thanks, Andrew. Appreciate it. So what I would like to do is give you a little bit of an overview of our previous discussion was more from the government side of things. And what I'd like to bring forward now is, why did I leave government? So I was in it for about 20 years, maybe a little less. And I noticed a lot of gaps in the system. And moving into a little more, let's say, energetic space, is I'm now part of Hexvarium and our team here, where we do spatial analytics on telecommunications. And we look at it from a different point of view. We were finding on the jurisdictional level that a lot of ISPs and large telecom companies were coming in, pulling permits, not really doing anything with them. And then once they did them, like I mentioned previously, we were struggling with trying to track them. How do we get them where they need to be? Where are our assets? What are we doing here? It was just a bit of a cluster constantly. I left about a year ago and I've joined Hexvarium, and what we do is telecom scenario modeling, and we take it from a different lens. We look more of it from a financial perspective. What is happening in a space where the build occurs? What's happening in your local boundaries? What companies are building in your area? Where should you start? Just from my own understanding, I have, is Google coming in? Is Comcast in there? Is CenturyLink in there? Like, there's so many different companies that we just don't know. Who's pulling the permits? Why are they pulling them? What's going on in our streets? 10 permits came in because they're pulling up the sidewalk and the asphalt, and we don't really know if they're connected or not. ISPs come in with subcontractors. What are their names? Are they connected back to this original project? So it was so scattered that it was causing us so much headache that we decided that we needed to kind of pull it together. So what I did was I've joined Hexvarium, and now we're looking back, and I'm going back in time a little bit, and I'm helping some of the jurisdictions that were a little more confused in the space, and we're trying to place a little more steady understanding of what's happening down there. So we have a product called HexMap, and we work with government agencies so that we can understand a lay of the land. Fiber builds, from our perspective, we look at return on investment. So return on investment comes, where are you going to build that fiber network? What's happening in those areas? And our HexMap and map that that I'm going to pull up right now, we're able to take this from a level that allows us to better understand where those fiber components are. Who's in your area? What are the demographics? Where are your vulnerable populations? We use approximately 200 data sets with each deployment of a HexMap analysis. We take that information and we put it into a concise report that allows you to take a look at what's happening within your jurisdictional boundaries. And then we go from there and we navigate that in a space where we are able to have talks with the ISPs that are coming into your area and better understand how that is mapped out. Part of the items that we provide is a these are more from, from an ISP point of view, but, you're going to get market assumptions. Where are they going to build? What are they going to be doing in that localized area on the ground? What are the costs? Market profile is who's in there? What are the components of the demographics of that area? Distribution. How many are they going to be usually putting in? Where are the lines going to go? Then we're going to look at more of each scenario we run according to the inputs that are provided to us. When we have a presentation, we are looking at, who's in the area. So we can give you a better understanding of who are the companies that are doing work in your area and what exactly are they providing. Some of them will come in with a 2 or 3 year subscription service and allow your residents to hook up to there, and then they kind of drop off after that. And so it is a money market like no other, and it's pretty aggressive. And so to be prepared to be able to take a good look when those franchise agreements come in and better understand where you stand and how you navigate that forward is very, very helpful. We've had a few successes. We can do a whole state. We can do small jurisdictions, large jurisdictions. We can put in a custom polygon of areas that need to have a better look at what's happening in those areas according to demographics, population, businesses, residents, and give that feedback back to the jurisdiction so that they can have these open conversations with ISPs and not hide under their desk because they feel pushed around by trying to better understand that world. And like our previous presenters have mentioned, that only just came into play after COVID when we couldn't access everybody to the internet. And we had to make sure that they had accessibility. And we just, a lot of us in certain areas of the states, we failed. And using that money properly, if you do have the ability to go out and grab a piece of it, if you do or do not. It's just really good to say, okay, where do we start first? Do we start in the rural areas? What's happening in those rural areas? And we can come in and at Hexvarium and take a look at what's happening in those areas and give you a better understanding of the lay of the land. We can also give you lots of information on speeds, mix. There's a lot of Ookla data out there. There's a lot of broadband data, FCC data. We have access to a lot of the various different data components that allow us to do a analysis of the whole. And we want to make sure that we're feeding that in a way that allows you to have these conversations. So I wanted to make sure that everybody understood that where we're at with that. And you can reach me at Hexvarium at Catherine@hexvarium.com. I will leave the information. And so thank you so much for taking the time today and come in and listen. And so I'd like to bring everybody else back, all the presenters back together so that we can answer any of the questions that you have.
Thank you, Catherine. That was a great presentation. And thank you to all of the presenters for coming on and giving us this great overview of broadband mapping. We do have one question from the chat currently, and I believe this question is for Nick. How do you download data for GIS coordinates from Bad Elf, and is it in real time?
Yeah, it's a great question. Sorry, my camera got a little messed up there. So there's a couple answers here. So Bad Elf, we live in a world that's called BYOD, bring your own device, not BYOB. Don't be thinking about beer. It's a little early for that. But what I mean by bring your own device is you take your cell phone, your tablet of choice, and you Bluetooth connect our GPS right to your device, right? So no longer do you need a GPS and a dedicated, what they call data collector. So your phone becomes a data collector. Because of that, we can then work with a lot of different apps in the world. So if you're in the Esri ecosystem, which I hope you would be, in field maps, for an example. So Bad Elf collects the high accuracy data, but it's actually being collected in Esri. And so Esri will real-time display data. You can be collecting that asset and somebody can be sitting behind a dashboard or in front of a map at the office, and you will see real-time data being collected. The other thing I'll say is Bad Elf has our own app. It's -5% of what Esri has. It's really just to connect us to RTK networks and things. You can collect data there, very simple data, but it would not be live. So short answer is yes, you can get it real time. You can download it via the internet. You could also airdrop data. You can download it via USB. You can email it out of the data collector. So there's lots of different ways to do that. So hopefully that answers the question.
Hey, Nick, maybe I'll just jump in and add into that on the Esri side a little bit. The thing I wanted to mention there is integrations with other applications and products. You know, because say you're using field maps or Survey 123 or Quick Capture, all that content is stored in the GIS. One of the things that we've been doing is working on integrations with other systems where that, I think, Catherine, you talked earlier about CityWorks and the asset management approach there. Something that a lot of people don't realize is we have direct integrations with CAD systems too, like Autodesk products. So if the end goal is to bring the content that you've perhaps captured in the field with one of our mobile applications and a Bad Elf GNSS receiver and bring it to CAD, there's just a seamless integration right there that you can take advantage of. So look for those other opportunities to integrate content that you capture in the field rather than just necessarily downloading it to a CSV or whatever format you're looking for.
Thank you for that, Jeff. I have a question from the 811 side of things, because that's where I sit, is in the call before you dig. So what would you recommend to cities, municipalities in terms of getting started and understanding where these assets are? Do they start internally with an ROI? Do they start with a consultant? Do they start with Esri or Bad Elf? Where's the starting point for most of these cities?
Well, I will speak on what I know. So usually what I did was a strategic plan. Things are changing so much. You know, we used to sit on, 5-year strategic plans, but because things are moving so quickly, I switched up to a 2-year strategic plan. And then I switched from actual words to infographics because it sits on somebody's desk and they don't want to read it. And so moving it into a space where they can look at it and understand it and bring it in front of people all the time, and getting it in front of a committee at a jurisdictional level and getting it funded. So there are funds out there, but asset management, we don't realize there's a problem until it's broken. We don't realize there's a problem with our water system or any other system, sewer, until there are pipes broken in the street. And if we can't shut them down, it's because we don't know where they are. And so we want to make sure that we're bringing that forward and, bringing examples and then putting it together in a infographic / document that's not too long and not too, boring to the point where they don't want to hear it. But examples really help. Gather those examples throughout the 6 months to a year and start writing them up, and then start putting them inside documentation and saying, you can't do that because you don't know where this is. Oh, you can't do that. You can't shut the valve off. I'm sorry, it flooded, but we don't know where that valve is. So bringing it more back around to them and allowing them to feel it and hear it is better, is what I've noticed happens and works in my, experience.
I think looking out to a lot of open data sites, a lot of content, a lot of infrastructure content's there. It's managed by cities and counties, and they keep it in a GIS, but we're seeing more and more of that information being shared through open data sites. So hunting, whatever your region is, looking for the GIS content that's out there, trying to source it if you can. I think there's more and more of it. So taking that opportunity to look would be a good idea.
One thing, just to jump in to follow up on Jeff's comment, not to plug Esri even more, but there are conferences and different types of organizational events that might be a great place. There's one called IMGIS, or Infrastructure Mapping GIS, I believe. That's an Esri conference that totally focuses in on utilities, and broadband telecom is a large component of that. But there's also tons of different state organizations. For an example, in Texas, where I reside, we have something called Tagadim. And Tagadim is actually an organization for IT managers and directors of state agencies. But there's a huge contingency there where they'll talk about telecom, for an example. So just want to throw out another way would be going to some industry events. That would be a great way to network and find out about the industry.
Nick, do you participate in any local GIS user groups too? Because I think there's those out there throughout the country too.
Absolutely. Yeah. So in the Texas area, Bad Elf is part of SCOG, so the South Central ARC Users Group. And depending on where you are, and I know Sara is part of SCOG, I believe that's how I maybe met Sara originally. But depending on where you are geographically, not just in the United States, but across the globe, there are user group meetings, whether it's SWUG, the Southwest Users Group, or SHRUG, the Seven Hills User Group. You name it. EURISA is a great organization that has a bunch of geospatial components there as well. Obviously, the American Society of Civil Engineers, any of the engineering groups. But yeah, Jeff, there's lots of local organizations. Oh, and I should mention that most states also have a GIS group as well. So in Arizona, where I used to live, it was AGIC, the Arizona Geographic Information Council, or Jeff, I think you're maybe in the Redlands or California area, CalGIS, or in Texas, we have TINRIS, and you can go across the country and find their independent organizations as well.
All great information. Thank you. So one of the other questions is, what do you all foresee as the biggest challenge for telecom in the future? Like, what are we looking towards?
I can start, but I may ask Andrew to follow up after this, because Andrew is definitely in the front lines every day doing this, right? And I know, just knowing Andrew for the last half a decade or plus, he's seen the different waves in telecom. I think some of the biggest challenges is the talking to walking. There's a lot of excited, conversation about these things, but how do you get started? How do you actually dive in? Where's that first step take place? I think also there's a lot of new technology out there, and I think the technology can be slightly overwhelming when at the end of the day, we're really talking about telecommunication design and engineering and servicing. I don't know, Andrew, not to throw you under the bus, but do you have any from the front lines, any thoughts?
Yeah, so I guess my initial thoughts on it are the biggest challenge that we're seeing is actually finding space for these utility providers in the telecom industry that want to come in and install a new network, being able to locate and find space for them to install this network. There's a lot of competition. Like I said, I've worked with Google and Facebook, and everybody wants to be the first to market. But if they're not the first to market, or there's not enough space in there, they generally don't want to take it up and provide the telecom backbone to that area, and they'll just kind of back away from it. I think that's the biggest challenge that we're seeing. And then, like you said, there's so many different technologies, and there's so many different people who want to quickly jump onto the technology, but don't necessarily understand its capabilities or how to fully utilize it. And so we're getting half utilized assets in the industry, right? And nobody's fully utilizing the software to their maximum capabilities. I'll go back to, like I said, with the fiber optic splicing software. Some companies do it really well. Other companies don't use it that well to manage their infrastructure. It's a powerful tool to be able to isolate outages, to manage your inventory, to manage and trace signals. But it takes a lot of overhead or staff in order to manage data like that because it continuously has to be updated. And so you have to be invested in it. You have to be willing to put in the time, the effort, and the resources to continuously maintain that. And to me, those are the biggest challenges that I've seen in the almost close to a decade now in the industry.
So of those challenges you just mentioned, Andrew, there's a lot of funding out there for broadband right now. How can that funding help alleviate some of that? What is that funding available for? Do we know anything about how to apply for those things and kind of get the funding aspect piece started? Because I know for cities and municipalities, they're on very tight budgets and they need to find money to do some of this work.
Yeah, so Nick had mentioned it earlier, and I'll defer back to him on the government funding aspect of it because he's pretty knowledgeable on that. It sounded like, but there is a lot of funding that the government's providing in an attempt to expand the broadband network infrastructure, specifically fiber optic. Personally, I think that streaming services or video games, stuff that requires large data like connection in order to transport that data is going to drive the industry going forward. I think as we want to have higher quality movies streamed, higher quality sound, bigger video games, higher quality video games, stuff that requires that large data, that's going to drive the network. The broadband utility companies are the ones that would need to apply directly for the government funding in order to expand that. But again, like I said, the biggest issue that we run into is that a utility company comes in, they want to provide fiber optic access, but there's not enough space in the ground to be able to install it, or they get into the market too late and there's somebody there that's already going to eat up their market share, and so they don't want to invest in it. I guess the biggest thing I could say to anybody who's thinking about it is rush, get into it, apply for the funding, right? And get into the market and make sure you're the first one there, because I see no end to the market. Nobody's going to stop watching movies. Nobody's going to stop playing video games. The communication's not going to change. It's just going to continue to grow. So the return on investment is ultimately there in the industry, I think. Nick, do you want to provide a little more information on the applying for the funding on the government side of it? I know you had mentioned that in your presentation.
Is it okay if I step in real quick?
Oh, go for it.
Okay. So last April, I went to a workshop, a 3-day workshop in DC in regards to the BEAD funding. And a lot of these BEAD offices have been stood up. Each state is now has their own BEAD and broadband office. And a lot of information resides on their websites. You can go and look at your coverage on the FCC map that has been available there. You can look at what your state and areas have already been, the money that they've already received or being awarded shortly, or how to go in and get an award, how to write the documentation, how to navigate this space, and the criteria that goes around it. Not all funding is 100% given to jurisdictions. Some come with matched funds, which becomes tricky. Matched funds sit on shelves for a little bit until a city makes it a priority, because they might not have put it in their budget, and they might not have fiber matching funds available. So they will receive the funds and it will sit there for a bit until they do get them, and then they'll pull it out of the cupboard, and then we're dealing with inflation and all other things that occur during that time. So there's a lot of different things that come up with this, and you want to make sure that you're talking to the people at the epicenter. Some of the states that come to mind that came across in the presentations were doing really well was, if you want to look at one, is Louisiana. They came to the top each and every single time, and they had to put it in to effect because Katrina impacted them so heavily. And so now they're dealing with that was, you know, quite a while ago. And so they've just kind of been, they're ahead of the curve, shall I say, according to some, you know, other states that are newly minted broadband offices. So you want to check there. You want to make sure that even though you are an urban environment, you still might have access. Don't assume that it's all of it is just rural, and you want to make sure that you carve out your area and get a better look at what's available to you.
So Jay posted in the Q&A to check with your Public Service Commission. He mentions Wisconsin specifically. So each state has their own Public Service Commission. There may be local or regional ones as well. So thank you for that, Jay. Appreciate the comment. I wanted to ask for Jeff and Nick, how does this field data collection using a person and a GPS device and field apps compare to AI-based data collection using LiDAR and available public resources?
Want to start, Nick?
I've chatted enough. Go for it, Jeff.
Well, I mean, I don't have experience with the AI-based approach, so it's hard for me to comment on that. I know building software with AI technologies is a growing field, and something that at Esri we're looking at quite extensively to help streamline the way that you capture data. But you know, I think compared to where we were historically with GNSS-based data capture and mobile applications, things have evolved quite considerably. You know, it used to be that you'd have to enlist a surveyor, purchase survey equipment in order to get high accuracy locations. And quite often that would require hiring a licensed surveyor to do the work as well. But with organizations like Bad Elf, that's really opened up opportunities to kind of bring that high quality data capture to consumer devices and to GIS and non-GIS trained individuals. So I think it's evolved a lot. As far as AI goes, though, I'm trying to think of how location capture can be improved that way. I don't know that there's much. I mean, the information external to the location, yes, being able to, you know, use TensorFlow algorithms to kind of pull out information about an asset to classify it through AI. I think AI is, you know, where we're going to see the efficiencies, but you're always going to need that accurate GNSS location to know where it is in the ground. I don't know. What are your thoughts, Nick?
I'll actually jump in there really quick a little bit on the AI side of it. So like I was showing in my presentation, when we do our LiDAR drive out scans, you can get a really precise 3D environment. One of the things that we're seeing relatively new in the industry is taking that LiDAR point cloud data, making sure that it's classified, and then using algorithms to quickly identify the assets in the 3D environment and pull out that information without having a lot of people go in and manually digitally survey that information. For instance, we could spend hours going through and collecting points of sidewalks or roads or poles, but as long as you classify the data correctly when it's pulled and scanned in the environment, there's several softwares out there that you can use to automatically generate that information and put together a quick base map for you. That way you're spending more time reviewing the precision of the data, making sure that it's accurate spatially, and less time actually visually scoping the data, right?
Yeah, I would concur with Andrew. A couple things just to keep in mind here. So you can use things like LiDAR, like as you mentioned, drive down the street, do massive data collection, and through a process of filtration, and you basically you classify the different assets in the field, trees, hardscape, sidewalks, things of this nature. What I've seen in my experience is these algorithms with the big data sets, especially point cloud data sets from drones or mobile, systems like that, like the Google Earths of the world. Usually the AI or machine learning algorithms can get you like 80 to 90% of the way there. Well, if you're collecting 10,000 telecommunication poles and it can get 9,000 of them, there's obviously benefit there. I will say a couple things. The other 15 or 20% is usually still a in-person, somebody doing a quality control, due diligence process, reviewing the assets that were pulled out by the algorithm, going in, collecting ones that were not collected, things that were obstructed by view. There's environmental factors to consider. So there's still a hand involved, and I would guess Andrew would say that's still the case. The other thing I would say is you still need high accuracy GPS data points to tie down data like mobile LiDAR, like drone data, photogrammetry, where you want to connect it into, street center lines and other geodetic monuments. And so what's nice, as you mentioned, Jeff, is you no longer have to have a survey department run out and roll to do that. You could have a GIS person with field maps, quite frankly, do it if you needed. And then, start tying all these different data, discrete data sets together. So I think there's opportunity where these new remote sensing technologies and AI are definitely helping. But here's a great example. So if you collect cable pedestals, right, those things that look like R2-D2 in people's yards that bring in, the internet connection to a home. Well, mobile LiDAR will do great finding out where it is. What about looking inside of it? So the moment you have to pop a pedestal, you have to look under a utility manhole, you got to start looking on the backside. Like imagine you have a telephone pole and the unique ID of the telephone pole happens to be on the far side and you're driving the street. So you're unable to collect the ID number. So my point is embrace the technology, it's here. And if you don't, you're going to get passed by. And but do your due diligence, right? Like you can't just assume everything is going to work correctly. Last but not least, I do want to make mention there is sort of an ethical debate here, as we talk about if there's 10,000 polls and the computer software pulls out 9,000 of them, what happens to the jobs wrapped around the people that used to pull those things out? And I just want to say that think through these decisions where you need to have labor, where you want to automate, right? Make sure that just because you're automating, you're still doing your ethical diligence and making sure that the data being produced, because, and I'll stop and be quiet, but I bet Andrew would say, I've seen some really bad automated results where you're like, holy crud, this is terrible. And you'd be fired if it would it would not be good. So yeah, just some thoughts.
Yeah, I would concur with that. And I would say that as we utilize more AI generated information, like I was saying, the role is less me generating that data. It's more me quality controlling that data to make sure that it's accurate. And I think we're seeing that transition. The key benefit from it, though, is the rush to market. When we can map out large areas with LiDAR and we can bring that back, automate it, and then spend the time quality controlling it, it's a higher quality product and we get that broadband network to the market faster. So that's where I would leave that.
So we're right at 12:30 Central Time. Do any of the panelists have any last minute or closing remarks for our attendees?
I would like to say those of you who are part of a jurisdiction or a government entity, really start talking to your councils and your higher authoritative panels and people that are, helping you navigate forward, and start asking them, is this important to you? And if it is, then start scouring the internet and looking for templates of how to put a plan together so that you could put something in front of them and move this forward in the next few years. Thanks. Really appreciate being here.
So I will just say thank you to our attendees for joining us today. Thank you to our presenters. This was a great group of folks to have talking about one particular topic from very different sides of the aisle. So I appreciate you all joining us today. And this will be recorded or has been recorded, and the sessions will be available for the attendees. So thank you all. Have a good rest of your day.
Thank you, everybody.
Thank you.